Hi everyone, in this demo we'll talk about the new SQL Server 2016 feature called Temporal Tables. So this video is broken down into two sections. In the first section we'll look at what is a temporal table and how to actually implement it and how it actually works. In the second section, we'll look at a demo of how to actually implement this feature using T-SQL and how to query the temporal tables, and also we'll look at the performance impact on the system and also the limitations of this feature. So, so what is a temporal table? Actually, this feature was introduced in 2011 by the ANSI and International Standards of Organization for SQL. So the IBM DB2 and Oracle 11G, 10G, 11G, 12C were the early adapters of this feature. So what this feature is all about is that it keeps track of all the data changes that occur on a table, and then it provides you a mechanism to query this data anytime, any point of time, and at the same time you can enable or disable or re-enable this feature at any time. So it's a pretty robust feature when coming to the auditing your data. So if you're planning to if you're planning to audit your detailed data on a table, this is the feature to go. So so let's look at how it actually works. So, the first thing you do is you select a table that you want to audit, and which will be your actual table, which will be the temporal table, and you'll also have a table which will be the history table. So both these tables have the same physical structure and also the same data types. So basically, when you insert the data into your actual table or update, delete, the changes are kept track in this history table. So that is the idea and how the system works. And when you query the historical data using the predicates, of what data you're looking for, the SQL Server automatically rewrites the query, and it looks at both historical table and the actual table, and it will gather the data, and it'll combine them, and it'll provide you the result you need. So you really don't need to understand how it actually works, but you just querying the tables to actually get the historical or the current data. So how to actually implement this feature? Like I said, the first thing you're going to do is we're going to select the table that we want to audit, and also the table that we would like to store this audit data. So the first table will be the temporal table, or the actual table, or the actual data, the table we're planning to audit. And then there will be a history table where all the changes are kept track. um, and then the second step is actually we enable this temporal table, on the we enable this temporal feature on the actual table by using by adding two columns, or by using two existing date time two columns. So these two date time two data type columns are important because they act as a the validity period of the record. So this will be the start time and end time of a record, and these two columns will define the validity period of the record at any point of time. It can be the current record, or it can be an historical record. Every record will have a time period. So these period columns exist both on the temporal table and the history table. Like I mentioned before, these two tables should have the same physical design, otherwise you will not be able to implement this feature. And then we use special clause that this new feature exposes, which we're going to use to query these tables, which we're going to look into the in detail in the coming slides and video. So yeah, and coming to the final point, like why do we need this feature? Like I just said, I mean, in the existing versions of SQL Server, we use the features like triggers, the change data capture, or the application itself actually audits our data in another table. So it's it's expensive, it's complex, it's not an easy process. This feature will make it, in couple of clicks, you will be able to audit your data in, within no time. And the ease of querying this data, using just the T-SQL, and you, without knowing the knowledge of how this data is being organized between this, or the historical data or the current data is being organized between this table, it's completely transparent. So that is the best part of this feature. So so to understand this feature, we need to know how it actually works, by taking a simple example here. So let's say we have a table called order, and it has two columns, ID, transaction ID, or order ID, and the amount. So let's say we want to audit this table. So when we enable the temporal feature on this table, so we're going to add the two data type, two date time, two columns, the start time and the end time of, which will be our period columns of the table. So which will be also act as the, the validity, of the record, the start time and end time. And also we going to, in this, in this example, we're going to choose order history as our historical table, and which will also have the same physical design as the order table, including those two date time, two columns as well. So let's say, we start with the, say, we insert a record here, with the ID as 1, transaction ID as 1, and the amount as 100. So the start time will be the current date time, at the time the transaction has executed, and the end time will be the maximum time, date time, which is the August 31st 9999. So this will be, when you insert a new record, and so at this point of time you will not see anything in the order history. So it's just the new record stays in the temporal table or the actual table. So let's say you updated that record, after 2 minutes. So what happens? So when you update, let's say that particular record, that particular transaction ID with amount of $250, so in the order table, the amount will be reflected with the amount that you want to update, and the start time will be the time this update transaction is executed. So let's say, because we are executing this after 2 minutes, so you will see the start time will also be updated to that particular point of time, and the end time will remain the same. But at the same time, it creates an entry in the order history table, saying this ID, of 1, and the amount $100, with the start time of the original start time, the start time that we, when we first inserted this record, and the end time as the date and time of when the transaction was updated. Okay. So by looking at these two records, what it actually is trying to do is, when you query, when you find out, what happened to your record of transaction ID 1, you now know that it was first inserted, let's say 8:45 a.m., and it was, and then the validity of this record was only 2 minutes, and then the new record, was start from 8:47, which is after which is after the 2 minutes that we updated the record, and in the end time of, the maximum end time. So that's how it keeps track of the changes. So let's say we delete this record after 2 minutes. So on the order table, which is our actual table, so delete order where order ID is 1. So that record actually will be deleted from the order table, but in the order history table you will have a new entry, for that record, with the start time as the time when this record was updated or inserted, and the end time as the date and time when the record was actually deleted. So so what actually, so let's get a complete picture now. So basically we had an empty table, and we inserted a record, and there was no change to the order history, to the history table. When we updated it, the date time columns were updated both on the order and the order history, but when we deleted, we have a new entry in the table of when actually it was deleted with the start time and end time. So we now have a complete track of our data with when our record was inserted and when it was updated and when it was actually removed from the system. So this is how it works internally. So hope you guys understood the concept. It's very easy, it looks a little complicated in the beginning, but once you start playing with it, it's actually very easy. So let's look at a simple demo.